Well, thank you, Margarita, and good morning, everyone. Just quickly go through the findings of this work. I'd also like to thank our sponsors, the Department of Agriculture, Water and Environment, CRDC, and also the operational support from the University of Southern Queensland. My colleagues were Pam Piraway, Alice Mellan, Sergi Marchuk, and we have Chris Dowling advising externally and in kind to the project. So we are very grateful to him. And obviously our cotton growers, Neil and Loki Nass from Yargalen and Russell Clapham from Pittsburgh. So this project had two objectives, which were to look at how nitrogen fertilizer formulations were affected by wet and dry cycles within a growing season and how that affected the nitrogen supply to the crop, and also identify if ammonia-based fertilizers, in our case was urea, enhanced the losses of dissolved organic matter, or DOC, recovery in leachate. So we explored some of those mechanisms in our project. So there were two components in terms of activities: field experiments and lab experiments. In the field, these were conducted over 2 seasons in 2016-17 and then 17-18. Both of the sites were in southern Queensland and were overhead irrigated. We used a standard farm practice for fertilizer application. We also use a control. So the highest rate was 150 kilos of nitrogen per hectare. And we use root exclusion tubes to isolate the effect of the roots from the nitrogen and the soil nitrogen interactions and the soil nitrogen dynamics in the field experiment. And they were sampled separately and then compare the nitrogen in the tubes without the effect of the roots versus the nitrogen outside in the bulk of the soil. We conducted a number of sampling events along the season that were timed based on the crop development, the cumulative degree days, and also the irrigation events. And in the lab experiment, we conducted a leaching trial by simply applying a number of fertilizers, in our case, urea, DMPP, and calcium nitrate at the same rates that we use in the field. And then we measure a whole bunch of analyses conducted in the leachate, but importantly, total dissolved nitrogen and dissolved organic carbon. So this is just a picture of the leaching trials in the lab with the soil columns. And on the left, you could see the timing of the sampling events in the field, in this case, plotted against the cumulative degree days and the growth stages of the crop. In terms of key findings, we see that this is overhead irrigation systems in both cases. The background soil nitrogen mineralization rates were relatively low, but very consistent throughout the season. So it was a consistent supply of nitrogen throughout the season, but steady and fairly low. The cotton roots take up nitrogen very actively in the first 30 days after the crop is been established, and then sort of levels off or declines or stays. It doesn't increase significantly after that time. So the nitrogen applied early on in the season is quite important in terms of nutrition. The DMPP treated urea inhibits the conversion of hydrolyzed urea to ammonium, and therefore the nitrification. There's a significant effect of nitrogen priming that is observed within the first 60 days following fertilizer application. And that is mainly explained by displacement of soil organic matter from organomineral complexes, in which organic matter is not microbially available, is protected from microbial activity, is dissolved and released to the system, and then oxidized, and nitrogen and carbon is released from that process. Then we confirmed that in the lab experiments. The ammonium that is So from that process, ammonia is released to the system and becomes available after the fertilizer is applied. And then we looked into a rapid extraction test to look at dissolved nitrogen, which appears to be a more sensitive indication of nitrogen supply than standard methods using, for example, KCl extraction. In terms of the leaching studies, the displacement of soil organic matter from organomineral complexes in the soil by ammonium-derived fertilizer requires temperatures in the soil that are higher than about 20 degrees. So some of that can happen early in the season, but as the soil warms up and the season progresses, the effect can be more significant. Below 20 degrees, the rate of hydrolysis is too slow, and therefore there's no significant displacement of soil organic matter. And then high concentration of nitrate derived from the fertilizer, in the case of calcium nitrate, were not associated with any increase in the soil organic matter or DOC recovery in leachate. So the mechanism seems to be very specific for urea or ammonium-based fertilizers. Well, as I said, in overhead system, we hypothesize there is a very uniform release of nitrogen throughout the season, and this is perhaps explained by the fact that there is no significant wet and dry cycles as may occur in flat or furrow irrigation systems. The nitrogen priming effect that is associated with application of ammonium-based fertilizers may contribute significant amounts of otherwise microbially protected nitrogen to the supply of the crop. And as I said, this is only a significant process when the soil temperature is higher than 20 degrees. Ammonium that is derived from the fertilizer, which becomes fixed to mineral exchange sites during end priming, may not be immediately available for plant uptake. And DMPP-coated urea could be used as a strategy to reduce nitrate loss by applying fertilizer to soils when the temperature is above 20 degrees. In terms of outputs, we conducted a number of extension activities. We were invited by the Cotton Info Irrigation and Nitrogen Tours of 2018, where we presented some of this data. We also attended the Cotton Conference in 2017, and we organized or were invited by the Bernard Mary Regional Group to present our findings, and they visited our sites in 2017. And we also invited the growers over to USQ in Toowoomba, together with Chris Dolin to discuss the results of our research, and the advisors were with them, so that was a good exercise to communicate our findings. And there's a couple of journal articles that are under review at the moment. So thank you very much for listening. Again, thank you to our sponsors, and especially you, Marguerite, for all the support over the years. Thank you very much.